for example 3, 2x squared plus 9x minus 5 equals 0. So it looks like we have our standard form of highest to lowest power equal to 0. However, this time, notice the lead coefficient is 2. So let's isolate our variable terms first. That gives us 2x squared plus 9x. We'll have to add 5 to both sides of the equation here. So 2x squared plus 9x now equals positive 5. And to create a lead coefficient of 1, each term will need to be divided by the coefficient of 2. That leaves us x squared plus 9 halves x equals 5 halves. Now don't worry about the fractions. We'll be able to work with these fractions. So we do have everything now in the proper form. A lead coefficient of positive 1 is needed. So let's go ahead and find half of the coefficient of our first degree term. Half of 9 halves simply means 9 fourths. And then we'll need to square 9 fourths. That means 9 squared is 81. 4 squared is 16. So 81/16 is the amount that we will need to add to each side of the equation to create our perfect square trinomial. So that will look like x squared plus 9 halves x plus 81/16 now equals 81/16, and we had a positive 5 halves on the right hand side already, so plus 5 halves. Do you notice that these denominators are not the same? So we can't add those fractions until we have common denominators. So we'll look at 81/16 added to 5 halves. 5 halves needs to be built up, so its denominator is also 16. So 2 times what would make 16? 2 times 8 makes 16. Therefore, the numerator has to also be built up by a factor of 8. 5 times 8 makes 40. So 40/16 added to 81/16 will give us some amount of 16ths, right? So 81 added to 40 is 121/16. So now we have the sum on the right-hand side of the equation. We can go ahead and rewrite our equation as x squared plus 9 halves x plus 81/16 now equals a total of 121/16. Let's talk about factoring this perfect square trinomial. So we know that x squared comes from x times x, and we know from finding half of this coefficient 9 halves, we ended up with 9 fourths. It's positive 9 fourths. So I know that plus 9 fourths is the factor needed in this binomial. Now we're ready to take the square root of each side. Remember again, we're looking for the positive and negative square root. So this equals plus or minus 11 fourths. Now let's simplify what we have here. X plus 9 fourths will now equal plus or minus 11 fourths. We can now set up two separate equations to solve and get our solutions. So one equation is x plus 9 fourths equals negative 11 fourths, or the other equation is x plus 9 fourths equals positive 11 fourths. So when we go ahead and solve this first equation, we'll be subtracting 9 fourths from each side of the equation. Notice that both fractions are negative, so you're actually adding 11 and 9 to get negative 20/4. So that would be simplified as x equals negative 5. In the other equation, we're going to subtract 9/4 from each side. And 11 minus 9 would be 2/4, and it's a positive 2/4. That's the same as positive 1/2 when you reduce. So our two solutions are x equals negative 5 and x equals 1/2. In example 4, you might have noticed already that our lead coefficient is not 1. We have 6. So 6x squared minus x minus 5 equals 0. So what we'll need to do is first isolate our variable terms on one side of the equation. 6x squared minus x equals, and to move this 5, we'll be adding 5 to each side. So we have 6x squared minus x equals 5. So what we'll need to do is divide each term by 6 in order to get a lead coefficient of 1. So now we have x squared minus 1/6 x equals 5/6. We're looking now for half of negative 1/6, and that would equal negative 1/12. The next thing we need to do is take negative 1/12 and square it, and negative times a negative will give us a positive 1 over 144. We're starting with x squared minus 1/6 x plus 1 over 144 equals 1 over 144, and it looks like we had a positive 5/6 already on the right hand side, so plus 5/6. So in order to add these fractions, we need to convert 5/6 into a fraction that has 144 for the denominator. In other words, 6 times something makes 144. So you could use your calculator and enter 144 and divide that by 6, and you're going to get 24. So 24 is the factor that both the numerator and denominator need to be built up by. And 5 times 124 is 120. So what we're really adding together is 1 over 144 and positive 120 over 144. So our equation now is x squared minus 1/6 x plus 1 over 144 equals, looks like that's 121 over 144. So let's think about factoring our perfect square trinomial, and that will be equal to 121 divided by 144. So we know the first term is x, and looking back to our previous steps where we found half of negative 1/6, that gave us negative 1/12. So I know to use minus 1/12 in this factoring. We're ready for square root property now. Take the square root of each side of the equation, considering both positive and negative square root. So on the left side, we have x minus 1/12, and that is equal to plus or minus the square root of this fraction. Looking at these numbers individually, 121, square root of that would be 11. Square root of 144 is 12. So now we have x minus 1/12 equals plus or minus 11/12. Let's set up our two equations. X minus 1/12 equals negative 11/12. Or we're going to have to solve x minus 1/12 equals positive 11/12. So when we go ahead and solve these, first I'll add 1/12 to both sides of the equation. Negative 11 positive 1. That gives me negative 10/12. Since those are both even numbers, it looks like we have some reducing to do. And that would be negative 5/6. For the other equation, again, I'll start by adding 1/12 to both sides. So 11 plus 1 makes 12. So it looks like we have 12/12. In other words, x equals 1. So one solution is x equals 1. The other solution, x equals negative 5/6. All right, in our next example, we have negative a squared minus 5a plus 14 equals 0. And you might think that this lead is 1, but it's actually negative 1, which is not the same thing. So we'll start by isolating our variable terms, and then we will make our lead coefficient positive 1. So we'd have negative a squared minus 5a equals how much? This time we have to take away 14 from each side of the equation, so we have negative 14 on the right. In order to convert this to a positive 1 coefficient, simply divide all terms by negative 1. So whatever the coefficient is, if it's not already 1, you're going to divide by the coefficient that's given. In this case, negative 1. So I now have a squared plus 5a, because negative divided by negative makes it positive 5a, equal to, again, negative divided by negative. So this quadratic equation now is equal to positive 14. So now we're ready to find half of this coefficient and square it in order to know how to write our perfect square trinomial. We'll look for half of 5, which is 5/2, and squaring 5/2 we'll have 25/4. Now what I need to do is add 25/4 to both sides of the equation. So that would look like a squared plus 5a plus 25/4 equals 25/4 plus 14. But 14 over 1 doesn't have a common denominator. So what we'll need to do is build up 14 over 1 into a fraction that has a denominator of 4. So it might be obvious that 1 times 4 would make 4. Therefore, the numerator also has to be built up by a factor of 4. So 56/4 is the equivalent to 14 over 1. So let's go ahead and do our factoring. On the left-hand side, we're going to have our quantity squared, and our middle term, remember, is going to be 5/2, and since it's positive, it's plus 5/2. So a plus 5/2 quantity squared now equals 56/4 plus 25/4. That looks like a plus 5/2 squared is some amount of fourths. 56 plus 25 is 81. So 81/4. We're ready now to take the square root of each side of our equation. And we're considering both the positive and negative square root. So a plus 5/2 could equal the negative 9/2, or a plus 5/2 equals positive 9/2. So in case you're wondering, where did that 9/2 come from? Remember, we're breaking apart this square root. So the square root of 81 is 9. The square root of 4 is 2. That's our quotient property. So we're ready to do just one more step to solve for a. We'll subtract 5/2 from both sides of the equation. And since both of these fractions are halves and both of the numerators are negative, we can conclude that a is equal to 9 plus 5, which is 14, negative 14 halves. So in that first equation, we get an answer simplifying as negative 7. And in our other equation, we'll subtract 5/2. So 9 minus 5 would make positive 4. Denominator is a common denominator of 2. So here it looks like a is equal to positive 2. Two solutions, a equals 2, a equals negative 7. So what you want to make sure you have when you're working with these quadratic equations and completing the square, your lead coefficient must be positive 1. If it's not, you might have to work a few steps in order to get that lead to positive 1. Then you're going to take half of this middle coefficient, square it. Add that squared amount to both sides of the equation. Then go ahead and go back to using square root property. Consider both positive and negative square root. You should then have two linear equations to set up and two solutions. And since none of these problems were application problems, we are going to keep answers that are negative numbers. I hope you found this tutorial helpful.